So it is with extreme pleasure that I welcome all of you to Innovation Day here at Hexagon Mining Division's Summit 2023. I'm a professor of Earth and Environmental Sciences at the University of Michigan, and I teach classes and do research focused on energy and mineral resources, upstream supply, downstream demand. And what I want to walk through for the first few minutes of this afternoon session are some things that I think about all the time through the lens of mitigating anthropogenic climate change and making life overall better around the world for the roughly 1 billion people who don't have access to electricity and roughly 3 billion additional people who don't have access to electricity 24/7, 365, which is the norm in the global north. When I think about convenience through the lens of electrification, I drive an EV, I have solar panels, I put in heat pumps, and I did all of that, one, to capture the tax credits that I'm privy to in the United States, so it made good financial sense, but also because I feel that it's the morally just thing to do to reduce my own personal and my family's impact on the environment. When we think about innovation, we as a mining industry need to mine, if we take copper as an example, as much copper in the next couple of decades as we have mined since the dawn of the Copper Age. And if we think about humans transitioning from the Stone Age to the Copper Age, we didn't run out of stones. And we transitioned from the Copper Age to the Bronze Age because we didn't run out of copper, but we figured out how to alloy tin with copper to make something stronger. And what the mining industry has the potential to do now is to help the entire world, all 8 billion plus members of our global society, make an advancement that is the greatest challenge society has ever faced. If you think about how rapidly we've advanced since the dawn of the Industrial Revolution, we're going to hear about advances in farming. We're going to hear about innovation with respect to gender parity, innovation with respect to technology, innovation with respect to underground, above ground mining, innovation with respect to global supply chains, innovation with respect to diversity and inclusion and accessibility. And I like to suggest that as an industry, we have to take an all of the above approach, all possible solutions that have to get us where we need to be. So if you'll give me a few minutes to sort of set the stage, I'm going to tell everybody in the room what you already know, but I hope the message that I deliver is one of optimism and hope. I'm a father of 4 kids, aged 17 to 25, and for them, I'm optimistic that the collective we in this room, we can innovate to supply the world with the metals that we know we need so that we can transition to an energy infrastructure that is less deleterious to the environment. If we look here at the climate goals of the U.S. Inflation Reduction Act, which was passed by President Biden and our Congress last year, what you can see are pathways from our current emissions to much, much, much lower emissions in 2030, 2035, 2040. And by the way, if anybody wants a copy of the presentation, I'm happy to send you the slides. And when you look at this, what a lot of people take away is, yes, we need to reduce carbon emissions. Well, how are we going to do it? We're going to do it by electrifying everything. Now, I don't mean tankers on the oceans and airplanes in the sky. But if we think about everything we use in our daily lives, from how we cook, how we heat hot water, how we move on the ground from A to B, all of the various modes of transportation from individuals to trucking fleets, how we heat our homes, how we air condition our homes, as air conditioning will become increasingly important in regions of the world that are now experiencing more frequent heat waves, and we're seeing mortality rates increase in those regions. So we're not doing it simply because it's more comfortable to live in an air-conditioned room in the summer. We're doing it because it's better for individual and public health. Depending on the model that you run, if we're going to achieve the US climate goals, the European Union climate goals, the Paris Accord climate goals, it means that within the next 25 years, 90% of all of the primary energy that we consume has to be electricity. And all of that energy has to come from renewable energy resources. Some combination of hydroelectric, nuclear, perhaps small-scale modular reactors that are now being developed, and solar and wind. And it's going to be the growth of solar and wind that are going to contribute the biggest to reducing carbon emissions. That's going to require significantly increasing the amount of electricity that we currently produce. So if we think about energy in terms of primary and secondary energy, right now globally, electricity is about 20% of all of the energy that we consume. We need to increase that by at least a factor of 4 to 5 in order to transition everything that we use that currently relies on combustion of fossil fuels to renewable energy resources. So electricity has to go up, and we see this if we look, for example, at the United States. If you squint, all of the blue dots represent currently operating utility-scale wind farms. And all of the orange represent currently operating utility-scale solar. And there aren't nearly the number that we need in order to become carbon neutral. This is what the map looks like by 2050. That's a massive change, massive. And I get asked all the time by students at the University of Michigan, can we do this? And my answer is yes. Absolutely we can do this, because one of the things that distinguishes humans from all other members of the animal kingdom is our ability to ideate and to innovate. And we can do this at an unprecedented scale, and it's going to take all of the creative minds in this room and in this conference center to make this happen. When we look at wind turbines, for everybody in this room, this is what you see. You see all of the metal resources required to make a wind turbine operate. When we look at a solar cell, this is what you see. You see all of the metal resources required to make this solar cell operate. Similar with an electric car. Electric cars are far simpler than combustion engine vehicles, an order of magnitude fewer parts. They're a lot more convenient if you have access to charging where you live so that you can charge overnight while you're asleep. But they require lots of metal resources. When we look at the periodic table and we look at the colors here in the top center, all I want to highlight with the periodic table are each of the elements that has a color is an element that right now is considered by the global north a critical metal or a critical mineral resource, which means we need that element in order to build wind and solar and electric vehicle infrastructure. We can't do it without these metals. One of the things that everyone in this room is acutely aware of is that if you look at the data here for copper, cobalt, and lithium, in blue, as a function of time projected out to 2035, is what currently operating mines and mines that are soon to be operating will produce. If you look at the two colored lines, green and orange, that's how much society needs to achieve our carbon neutrality goals. So for a metal such as copper, if we're currently producing somewhere on the order of 22 million tons per year, we're going to need pushing 30 million tons per year for several decades to build out the renewable energy infrastructure that we need, which means that production has to increase at existing mines, and new mines have to come online at a speed that's unprecedented. If we look here at data from the IEA, these are data for copper. And you can see for 2020, 2030, and 2040, for the most robust climate predictions to achieve carbon neutrality, we need to increase copper to 30 million tons per year by 2030 and 34 million tons by 2040. And the question is, can we do it? And the answer has to be yes. There is no other answer. We have to do it. And the data for all other metals that we use to build renewable energy infrastructure, we can look at cobalt. Now, cobalt is a metal that's a byproduct or a co-product. It's not a primary economic target for mining companies. So we need to increase the amount of cobalt we're producing from currently operating copper and nickel mines and new copper and nickel mines that will come online within the next few years. But you can see we need to increase cobalt production from 423,000 tons by 2030 to 661,000 tons by 2040 from right now 159,000 tons. That's a big jump. Can we do it? Yes. Similarly, we can look at lithium, right? Lithium, when we talk about lithium-ion batteries, that is fundamental to all of our efforts to build out an energy infrastructure reliant on grid scale and local scale battery storage, whether it's lithium iron phosphate batteries like I have in my basement, or lithium ion batteries that are in an electric vehicle that we drive. We know that lithium production has to increase significantly. We know we have to innovate. We know there are companies now that are working on ways of extracting lithium from brine without using pools at the surface, because using pools at the surface is incredibly water intensive. And where most lithium is mined, in the lithium triangle in South America, water is a precious commodity. So we have to innovate, and we have to do it better than we've ever done it before. We see the same thing with nickel, and we see the same thing with rare earths, where neodymium is the dominantly used rare earth metal to make permanent magnets. We also have to think about where all of these minerals are sourced. It's increasingly of concern to many countries around the world that a majority of these so-called energy critical metals or critical mineral resources are sourced in a very small number of places. So we have to think about innovating the supply chain for these minerals, and we have to think about diversifying the locations where we process all of these minerals. For example, in the United States, we have one rare earth element producer, and all of that concentrate is shipped to China for final processing. So we have to think about how can we innovate and process in new places that allow us to diversify the upstream supply chain for all of these energy critical metals. We're seeing this play out in real time if we look at nickel. Indonesia, a decade ago, was a small player on the global market for nickel. Now it dominates the market. And the map on the right side, on the left side of the slide, shows you mines that have come online within only the last few years. Nickel is one of the fundamental elements in cathodes in lithium-ion batteries, and a higher ratio of nickel to cobalt gives you greater energy density, which allows you to travel further in an electric vehicle. So nickel demand will only continue to increase, and Indonesia will continue to play an extremely important role in producing this important metal. In nickel laterites in Indonesia, they also contain cobalt. So we're also seeing in real time, as Indonesia becomes the global leader in nickel, we can look at projections for the amount of cobalt also being produced from nickel laterites, and we can see that cobalt production is increasing year over year. So the blue here is production in Indonesia, the orange is production in the Democratic Republic of Congo. So again, thinking about diversifying the supply chain for critical metals. It's happening in real time because we're innovating. One of the big hurdles to achieving carbon neutrality by significantly increasing renewable energy infrastructure is the length of time it takes to go from exploration, discovery, permitting, to production. So these are data here for lithium in Australia and South America, nickel sulfide, nickel laterites, and copper for the top 35 mining projects globally that came online between 2010 and 2019. And the average is 16 years. That's too long, right? That is simply too long. We don't have 16 years if we want to rapidly transition to renewable energy. We have to increase our ability to mine much, much faster. And this is happening in real time as well. So these are data for nickel laterites, and in the orange box at the bottom, I highlight 3 mines that after discovery and after permitting, from the date they pushed the button to go, 1 year they were producing. 1 year. Now, everyone in the audience can say, oh, that's China, oh, that's Indonesia, but what it tells us is technologically, the infrastructure can be built. And the people in this room know how to do it. I'm sure those of you who are involved in mine planning, construction, if I were to say go and gave you the capital that you needed and the workers that you need, you could do this. And we have to do it. We can't wait 10 years, 15 years, 20 years. It has to become the norm over the next decade that we're looking at time frames of 1 year, 2 years, 3 years from when we push the button go and when we physically have that mineral out of the ground and ready to be embedded in some renewable energy technology. Innovation also has to touch on what we historically thought of as mine waste. Think about the mines you have visited. If you've ever visited Bingham Canyon or Grasberg or Chukchi, how much mine waste is sitting on the surface that contains metals at grades that we can mine today economically? Or in the case of porphyry copper deposits, might contain tellurium that we didn't have a use for 20, 30, 40, 50 years ago. But now we need that for cadmium telluride solar panels. So it's also important for mining companies to innovate, to think about all of the so-called waste and how can we use that waste to produce metals for the so-called green energy transition. Now, among the challenges for the mining industry is that all of the downstream producers and manufacturers of renewable energy technology, they're innovating also in real time. So within the last month, Tesla makes an announcement that they're going to transition from a 12-volt to a 48-volt battery system. That requires less copper. Now, Tesla as a company has a small market share in total copper consumption globally, but nonetheless, this is going to impact how much copper we need. I mentioned lithium. The image on the left is one you probably all have seen, large brine pools that use on average 500,000 gallons of water per ton of lithium, and they have relatively high CapEx and OpEx. We're now looking in real time at engineering groups around the world innovating and coming up with ways to remove lithium from brines without ever using a pool on the surface. So this is happening in real time, and it will be revolutionary for our ability to produce all of the lithium we need. China, at a recent auto show, they also showcased one of their new EVs that has a battery that doesn't contain lithium. It's a salt battery. So think about that, right? This is a car that has a sticker price in US dollars that is below 10,000. So what does this mean for the future of lithium, and what does it require lithium companies to be able to do to innovate, to increase supply and reduce costs? When we think about rare earth metals, I showed some data for neodymium, right? It typically is the rare earth of choice. In a given battery electric vehicle, the electric motors, the permanent magnets, contain neodymium, typically 500 grams of neodymium per motor per vehicle. And we're also seeing innovation among companies around the world where they're looking at reducing the mass of rare earth elements in permanent magnets and even moving away from rare earth elements to produce permanent magnets that don't require any neodymium or other rare earth metals. This is a company now that is spun out of one of the US Department of Energy labs, where they've taken a relatively new idea and they have developed an iron nitride battery, an iron nitride permanent magnet, that has the same performance characteristic as a rare earth element permanent magnet. We're also seeing innovation in wind turbines. So this is a press release from another US national lab, Sandia, outside Albuquerque, New Mexico, and they have developed a prototype to produce electricity from a wind turbine that does not require permanent magnets. So this is happening in real time. So if I were in the mining industry, these are the things that I'm thinking about all the time. We're going to hear from someone during this conference who's going to touch on legal and policy issues. For most people in the room, the bottleneck for most projects now is permitting. How long does it take after you discover a deposit somewhere and you want to move it all the way through the stage of getting the permits to push the button to start building the mine? It's got to be much faster than it ever has been. We have to eliminate that bottleneck. Now, my last couple of slides touch on something that will also be a focus of some of the panelists we'll have over the next couple of days. This is a survey of 15 to 30-year-olds, asking them among all of the sectors that you can see there: mining, oil and gas, construction, manufacturing, transportation and logistics, financial services, arts and culture, high tech and healthcare, where they rank them relative to their own career aspirations. And mining is on the slide at the top, but statistically, it's at the bottom. Now, I've got 4 kids. My younger son is 17. He's finishing his 3rd year of high school, and he's fascinated by all things autonomous, all things, right? The ability to move people and goods by drones, the ability to use electric vehicles, the ability to transition everything to electricity. He's fascinated by that. But he also would answer the survey similarly. He envisions wanting to go into high tech, and when I push him and say, but Ethan, mining is as high tech as Apple and Google. The things that are being done in the mining industry by way of technologic innovation, they're on par with all of the other companies that people in this demographic think of as high tech, but it's not translating. So when students are finishing that 3rd year and 4th year of high school around the world, and they're thinking about, what do I want to study if I go into college? What do I want to do if I enter an apprentice program or a junior college or a community college program? They're not thinking mining. And so there's a need for the mining industry as a whole to think about how do we make sure that 15 to 30-year-olds want to work for us because they recognize how critically important our industry is to everything that they want, right? The same survey respondents will tell you that climate change is the most important thing for them. They will tell you that reducing their carbon footprint is the most important thing to them. They will tell you that convenience and technology are important to them, but it's not translating. And then the last slide touches on innovation through the lens of diversity, inclusion, and access. I'll leave this up for a minute and let you scan. These are not my opinions. If we look at the global workforce, mining has always been male-dominated. But does it have to be? My answer is no. The mining industry needs to take a look at the prospective talent and think about how to attract young, talented, incredibly bright, innovative women into the mining industry. I'm a father of 4, 2 sons and 2 daughters, and I think about this all the time. I've had hundreds, if not thousands, of conversations with my daughters as they have thought about who do they want to become, right? When they're all finished with school and mom and dad are no longer paying for things, and they wake up on a Monday morning and they're going to leave the house to go to work, who do they want to be? We have to make work-life balance important. Sure, we're always going to need people to drive a truck 12-hour shifts 6 days in a row. We'll need that. And I don't pretend that we're going to have perfect gender parity in every single aspect of the mining industry. But I can tell you this, part of my role at the University of Michigan, I work with a lot of undergraduate students, a lot of 18, 19, and 20-year-old women who are majoring in computer science and computer engineering and mechanical engineering. And I'll tell you what, they come into the university already far more mature than the male students. And I don't mean to denigrate male students, but they come in very mature, very capable. In the United States, women now outperform men entering engineering programs in math and science. How do we capture that, right? There's no magic pill, there's no magic switch, but how do we put in motion a process that when we look back in 2035, everybody in this room can say, you know what? I didn't do it on my own. But when I look around the world and I see all of this grid scale, utility scale solar energy, all of this grid scale wind energy, all of these battery electric vehicles, and I see emissions are down and down and down and down, not sacrificing quality of life for those in the global north, improving quality of life for those in the global south, improving access to health care, which requires mining, improving access to education, which requires mining, improving equity, inclusion, and access. We have to do this. There's only one plan. We now, when we look around the world at countries in the global north, it's clear that our elected leaders get this. It's clear that even those who will sort of say in a group they're not pro-renewables, they're pro-renewables. If you tell them that the least expensive way to build new energy is wind and solar. And I can promise you, anybody who has the ability to buy an EV and never have to go fill up for petrol, you're not going to go back to a petrol vehicle. So everybody in this room, the seed that I want to plant and the conversations we'll have starting in just a minute is, how does the mining industry writ large step up and make this happen? Because fundamentally, it all starts with us. We are the beginning of the supply chain for everything society wants, everything. Food, clean water, education, healthcare, everything starts with the people who are in this room. We don't have several decades. We have got to do this so that in 2035, everybody in this room can crack a little smile and say, I'm really proud that I was able to play some role in supporting the mining industry overall to rise to the greatest challenge that humanity has ever faced. So thank you very much. And I'm going to transition to invite now Rob Daw, who is Hexagon Mining Chief Innovation Officer, up on stage. Rob is also the proud father of 4 children, 3 girls and 1 boy. So Rob, as you think about innovation, and you think about that through the lens of mining, what do you view are the best opportunities and the biggest hurdles?
Yeah, good question. I think there's a lot of opportunities, and to go back to your point around the exploration side of things and the duration it takes for us to get these sorts of mines, you know, minerals are becoming scarcer and scarcer. They're harder to find, and ultimately they're harder to mine. We're getting deeper, the pits are getting bigger, and everything else. And so we really need to look at the ways that we innovate to make sure that these resources are still profitable and economical. And not only that, we're getting further away from our infrastructure. So from our ports, from our processing plants that we've already invested in, these pits are further and further away. And so, you know, the challenge for us is how do we continue to do this in that most profitable and economical and safe way possible? So I think there is a lot of opportunities there. We look at exploration. There's things now like using satellites to identify where ore bodies are, new ways that we can look at the core sampling to speed that process up. There's a lot of regulatory software and solutions coming out now around how we can advance those processes there in actually shortening the regulatory time. I mean, obviously, we're still dealing with government, so there's always going to be a little bit of time there. And then into how do we track our material much better. We're spending so much money up front in identifying where our resources are that, you know, for a period of time there, we're all about tons, moving tons. And now we're actually trying to really look at where have these tons come from and where they're going and optimizing that on the full supply chain. And then I think the final piece there is really around the fleet and making sure that we're leveraging those assets in the best way possible to make sure we're extracting that material, again, in the most optimal and safest way possible. The final sort of opportunity I think that we've seen in the mining side of things really is around safety as well. It's been a huge focus for pretty much every single mining company around the world in the last 2 to 3 years has been to make sure that we are operating in the safest way possible and to enable us to reduce those risks, whether that be a metal-on-metal collision or making sure we can monitor our operators so that they are performing their duties in the safest way possible as well, and obviously giving them as much support as well.
So all of this makes you optimistic?
Absolutely. I think we've got a really bright future. We can, but I think it's up to all of us in this room and outside of this room, anyone in the industry, we all have to buy into this vision, this strategy of what we want to do to make sure we are competitive and that we do support the world.
So as you think about the next decade, and you think about the innovations that are on the horizon, and the innovations that we don't even know yet exist because we haven't thought of them, can you give us maybe your top 3 areas in the mining industry that you would say are the most ideal low-hanging fruit?
Top 3. It's, I mean, there's so many, obviously, right? But I think, and you'll hear a little bit about this, and you heard from the keynote last night as well, I think autonomy has a huge opportunity in the mining industry to access some of these resources that are getting deeper, where we can't put humans, making sure that we can do that autonomously with these vehicles, down the path of EV in there as well, so that we don't have the emissions in some of the underground mines. Obviously, we can be much more aggressive in the open pit mines with autonomy as well, which makes those economics a lot better for us and obviously a lot safer as well. So I think that in its own right will give us a huge opportunity. There's other things like emissions that's going to reduce and everything also from autonomy. And then I think one of the other key areas is around analytics. So we're capturing so much data now in the world. There are opportunities there that we don't even know exist yet. We're seeing all of this information and data coming through, and we're starting to trend it, and we're starting to put some AI over it, but there's things there we just don't even know yet. And so when we then look forward into the next 5 years, 10 years after that, I think there's opportunities there that are going to arise for us that we're not aware of today, and that's the part that really excites me, I think, of the opportunity that we have in the mining sector.
So what strategies are you employing, or do you think can be employed across the sector to recruit the talent you need?
Yeah, I mean, from our point of view, it's about getting people encouraged into the mining industry early. So obviously getting out there, showing what's cool about technology first, and then what's great about mining. I think, I'm lucky enough, I'm from a part of the world where mining is pretty much the most spoken about thing in Western Australia. I don't know if there's any other industry apparently in Western Australia. And so we do see that whole ecosystem that really does bring people into the mining industry early. So it's a really interesting incubator that we have here. And obviously then how do we replicate that in other parts of the world of getting people to site? I think companies like your BHPs, Rio Tintos, they do it really, really well. They have the family days, they take people out, you get hands-on, you have the opportunity to see what mum and dad are doing at work every day, and I think that's a great way to continue to encourage and bring people into that industry.
So as we look forward to the next couple of days and we think about innovation, technology, digitization, electrification, what world would you want for your kids when they're your age?
Obviously, we still want a world, I guess, is probably the first point. We've heard last night with the 1.5 degrees, if we had cut our emissions by half today, we're still going to raise the world temperature by 1.5 degrees. And so for us, it's really about how do we contribute to that sustainability? How do we continue to evolve the technologies to make sure we are going to be more sustainable? And so for me, for the kids, I want them to be able to walk into a mining industry that they're proud of, that is sustainable, that has some pretty cool tech as well, right? It's got to be a bit of fun out there, and I think that's the big change, and that's where hopefully in the next 20, 30 years, that's where we'll be.
And the message you give them is, yes, we're going to do it.
Absolutely.
Not we can, but we will.
I think that's not a Hexagon thing. That's everybody in the room. That's everyone in the industry. It is going to take all of us to actually achieve that. And I think we're definitely on the right path. And I hope we can accelerate that.
Well, thank you very much.
Thank you.
Yep. It's great to have you here.